Hi students, welcome back. Today we're going to talk about stoichiometry, stoichiometry of solution reactions. That's going to be fun. So remember the 6 steps we had for stoichiometry. So calculating on balanced chemical reaction. First step, balancing the chemical reaction. The second step, converting information I provide into moles. Third step is mole ratio of my balanced chemical reaction. And based on the mole ratio, we can determine if we have a limiting reaction, yes or no. Step 4 is you use the mole ratio to assess the number of moles of my requested compound. It can be both the product or the reactant. Number 5, we convert the number of moles back to mass or any other unit if required, like milliliters or something like that. Number 6 is check your answer, especially pay attention to the unit. I have 2 examples to demonstrate this. But first I have the overview of the stoichiometry. This is what we had so far. Moles in the center. From moles to grams, I multiply with the molar mass. Here we are, and from mass back to moles, I divide. And the lower part here is only for gases. On the right-hand side, you have the number of items, so the number of avogadro you see in the middle. And we added molarity. So from moles to molarity, we divide with the volume. From molarity to moles, we multiply with the volume, both in liters, the volume. So now the examples. I do step by step. Calculate the mass of solid sodium carbonate that must be added to a 1.5 liter 0.1 m calcium nitrate solution to precipitate all the carbonate ions in the form of calcium carbonate. That's the precipitate. Calculate the mass of calcium carbonate as well. So, let's do it. First step, balance the chemical reaction. Well, we have sodium carbonate, that's a solid, because we had in the text it's a solid, plus calcium nitrate solution. And the products are calcium carbonate, this is my precipitate, that's a solid, and we have sodium nitrate. These are still in my solution, so we call them the spectator ions. Step 2, convert the provided information into moles. So what do we have? We have 1.5 liters and 0.1 m. So we multiply these. 1.5 liters times 0.1 mole per liter gives me 0.15 mole calcium nitrate. That's the amount I have. Step 3, mole ratio. So the mole ratio 1 to 1 becomes, with the product side, 1 to 2. And of course we're now interested in the sodium carbonate and calcium nitrate, and that ratio is 1 to 1. Next slide, I continue. So here we have a summary from the previous slide, so the reaction equation and the number of moles of calcium nitrate. So, step 4, use mole ratio to assess the number of moles of my desired or requested compound. We're looking for calcium carbonate, my precipitate. And with the mole ratio, we can see we have 0.15 moles calcium carbonate is available, and that means also 0.15 moles of calcium carbonate is produced. And we need, for the 0.15 mole calcium nitrate, we need also 0.15 mole of sodium carbonate. So we have the number of moles of our compounds we're asking for. Step 5, convert it back to mass or milliliters. So for the sodium carbonate, I have 0.15 mole, that's what I need. The molar mass is 105.99. When I multiply these two, that means I need an amount of 15.9 grams of sodium carbonate. That's required for this solution, for this reaction. And my precipitate, I just found out I get 0.15 mole of my precipitate. I multiply with the molar mass of calcium carbonate, that's 100.1, and then my result is I have a precipitation of 15.0 grams calcium carbonate. That's the first example, working with stoichiometry on solutions. The next is an example from the textbook. And that example is when sodium sulfate and lead 2 nitrate are mixed together, we have a precipitation of lead sulfate. Now the question is, calculate the mass of my precipitate, so lead sulfate, when I have 1.25 liters of 0.05 m lead 2 nitrate solution and 2 liters of 0.0250 m sodium sulfate solution when they're mixed together. That's the question. So the first step, balance chemical reaction. Let's do it. So we have sodium sulfate plus lead-2 nitrate, they're both solutions. Here's my precipitate, lead sulfate, and I have 2 NaNO3 are my spectator ions. When I would do a net ionic equation, so without only the ions that are reacting, is SO4 2 minus plus Pb2 plus becomes lead sulfate, lead-2 sulfate. For later on, I will have an example, and then we need the separate ions. So I want to pay attention to it a little bit, to the net ionic equation. Second step is convert the provided information into moles. So what do we have? We have 1.25 liters of 0.05 m and 2 liters of 0.025 m. So based on these, we can calculate the number of moles. First for lead nitrate. I have 1.25 liters times 0.05 moles per liter gives me 0.0625 moles of lead-2 nitrate solution. The other one, for sodium sulfate, I have 2 liters with a concentration of 0.0250 moles per liter. Gives me 0.05 moles of Na2SO4. Step 3, mole ratio. Well, we can see the ratio here, 1, 1, 1, and 2. So it's 1 to 1, it becomes 1 and 2. And we're more interested in the amount of my precipitate, so that's the PbSO4. So the ratio we see is 1 to 1. I have here a summary on the previous slide. So the reaction equation and the number of moles. And now step 4, use mole ratio to assess the number of moles of my desired compound. So now we have to find out which one is limiting. So, and we can see that my sodium sulfate is my limiting reaction because I have only 0.05 moles, and the other compound I have 0.0625 moles. So sodium sulfate is limiting, and when that is limiting, it also determines how many moles of my precipitate I will have, and that's the same, also 0.05 moles of lead-2 sulfate. Step 5 is to convert the information back to grams, or whatever unit we want, but we're interested in grams. So we know we have 0.05 moles of lead-2 sulfate. What we have to do is to multiply the moles with the molar mass of lead-2 sulfate, and that's 303.3 grams per mole. And we do that correctly. We have an amount of or precipitation of 15.2 grams lead-2 sulfate. Okay guys, this was an explanation on solution stoichiometry. What I suggest you to do, look at this presentation again, study chapter 15.3a. There will be an online worksheet on molarity and stoichiometry available for you on Schoology. And tomorrow I'm going to send you an extra practice questions on solution stoichiometry. All right, that's it for now. That's it for today. Enjoy it. Have a good day. Enjoy it, and see you again. Bye bye.